Example 4. The point 1, 0 is a point on the equation y equals f of x that satisfies the differential equation dy by dx equals x squared times 1 plus y squared. Part 1 asks to find the equation of the tangent line and use the equation to estimate f of 1.1. So first of all, we need a point. So we have that here at 1, 0. And we need a slope. So in this case, we're going to use the dy by dx to calculate slope. So dy by dx, when x is 1 and y is 0, okay, that's going to be 1 squared times 1 plus 0 squared. So plugging in 1 and 0, I'm going to end up with a slope of 1. So that's my slope. The equation of the tangent line then is going to be y equals the slope 1 and the coordinate 1 and 0. So putting in point slope form, I get that. Okay, so basically it's 1x minus 1 is the equation of my tangent line at that point. So using that, I'm going to say that f of 1.1 will be approximated by the y value on that line, on the linear equation at 1.1. So I'm going to end up with 1.1 minus 1 times 1. And that's going to give me 0.1. Okay, so that's my estimation of f of 1.1. That's an approximation. So that's part 1. Part 2 says solve the differential equation. So solve for f of x. What that's going to involve is going to involve separating my x and y's. So I'm going to have my y expressions, and I'm going to separate that with my x expressions. Okay, so I'm going to separate it and integrate that. So what I end up with then is I end up with dy. So I end up with dy over 1 plus y squared. And that's going to be equal to, when I separate the x's, I end up with x, keep the x squared on this side, move the dx to the other side here, and then integrate both sides. And I have to recognize that on the right side, that's power rule, but on the left side in red, that is not a power rule. Okay, we have to recognize that as an arctan. So integrating the left side, I end up with arctan of y, and that's going to be equal to x cubed over 3 plus c. Okay, so I want to solve for the plus c, so what I'm going to do is I'm going to input my x and y into that equation. So arctan of y is 0 is equal to 1 cubed over 3 plus c. Arctan of 0 is 0, so I end up with c is equal to negative 1 over 3. Okay, so once I have that, I'm just going to plug that into my expression. So arctan y equals x cubed over 3 minus 1 over 3. Okay, that's a common denominator, so we can put that in one expression. But I still need to solve for y, so I'm going to undo the arctan with a tan. So I end up with tan x cubed minus 1 all over 3. So there's my equation. This is the solution to that differential equation that goes to that particular point. So I now have the actual equation. So if I want, I could calculate f of 1.1. So f of 1.1, when I put this into that expression, I end up with 0.1107. So it's going to be, I'm going to round that to 0.111. And comparing that to my estimation, okay, here's my estimation. This is the actual value, so it is off by a little bit. We can see that it's pretty close estimation there.